Okay, question 7. We've got two cyclists ride on a hilly road and they go through the points that we can see here. So we can imagine this is a hill that they're going up, and we've got P, Q, R, S and T. It says the greatest overall change in gravitational potential energy for each cyclist is between which 2 points of the journey. So really we're just after what's the greatest difference. So between P and Q it's 20, between Q and R it's 15, and between R and S 35 take away 10 is 25. So hopefully we can see it's between R and S. Next one, we need our fat wobbly dinosaurs. So the total weight of one cyclist and bicycle is 700 newtons. That's absolutely fine. Calculate the total amount of work done against gravity when the cyclist travels from P to Q in the journey. So we need to go back and have a quick look at P to Q. So P to Q was 20 meters in height gain. So the vertical gain is 20. 700 times 20 equals 14,000 joules. That's a really nice question. Next one, your favourite. So we've got our GPE and MGH, and it wants us to find out the mass. So M equals GP over GH, or we could have done it this way, divide both sides by G and H, so they'll sit under here. So now that that's ready, we're just going to check the units. Energy's in joules. Gravitational strength is 10, and travelling from Q to R, so let's just skim back. So Q to R is 15. And now we're away. So it's the total energy, 11,250, divided by 10 times 15, which we got from the graph. And that equals 75. Again, a really nice question. Explain why the total amount of work done by the cyclist is different to the change in GPE. So what we're going to have is the cyclist is going, say, up a slope. They're going to have to provide some work to go over that total slope. They're going to have this height here, but as they're doing it, there's going to be some friction, and that's going to make some heat energy that will dissipate into the air. So work will be done to overcome friction or air resistance. This creates thermal energy, your old favourite, which will be dissipated into the air. The next part is, why do we need to lubricate the chains? And we know this is a way of increasing efficiency. We'll get less wasted energy, so reduce the wasted energy. So I'm after something to do with efficiency. Lubricating, decreasing it, garbage. Lubricating will increase it, perfect. C. And the last part is the kinetic energy of a cyclist is 2,800. The mass of the cyclist is 85. Calculate the velocity. So we know KE equals half mv squared. Now we've got to rearrange for m. So multiply both sides by 2. That's gone. Divide both sides by m. That's gone. And we know v squared equals that, but we want v. So v is the square root of 2k over m. And then we can plug our values in. That's as we want it. That's as we want it. So v equals the square root of 2k over m. 2 lots of 2,800 is 5,600. Divided by 85 equals 8.1 meters per second. It's a nice question, that, nice and easy.